Today I'm going to talk about inequalities and solving inequalities. But before we start that, let's recall a little bit about this idea about inequalities. Remember that in the real numbers, we could compare two numbers, say 1.5 and 4, and we would put a symbol in between them to say that 1.5 was to the left of 4 on the real number line, or 1.5 was less than 4. And we could draw that on a number line. We'd say, here's 1.5, 1.4 is over to the right, right? So there's the number 1.5, and here's the number 4. Right? And then we had other symbols. We had a symbol, something like pi. Remember pi? Nice irrational number. And perhaps compare that with the number 3. Pi is approximately 3.14, so it's actually greater than 3. Perhaps some negative numbers, -1, -7. Well, where do those lie? Let's think about this. Here's 0, -1, 2, 3, 4, 5, 6. -7 is over here. -7 is to the left of -1, so -7 is less than 1. I'm sorry, it is less than 1, but it's less than -1, or -1 is actually greater than -7. Alright, now we're going to look at putting some ideas into play with x and inequalities. So let's graph all the numbers greater than or equal to 3. Greater than, there we go, greater than or equal to 3. Luckily in algebra we have an easier way than writing all this out. All numbers greater than or equal to 3 is the same thing as writing x. These are all the numbers that are greater than or equal to 3, right? Which is nice. Very compact way of saying the same thing. Alright, well, let's put our number line. Here's 0, 1, 2, 3. I want greater than or equal to 3, so certainly 3 is in there. How about 4? Sure, 4. 5, oh, okay. Well, you can see we could keep going with the integers with no problem. 6, sure. But what about in between 3 and 4? Yeah, there's a number that's greater than 3, and, well, between 3 and 3.5, there's a number that's greater. And we'd get all bunched up in here, right? That's what would happen. So we have a nice way of graphing this rather than trying to point out every single number. It would get very tedious, right? So we'll start with 0, 1, 2, 3, 4. Give myself some indication of scale. And then what I'm going to put it in a different color. Greater than or equal to 3. If I want to include 3 and all these numbers to the right of 3, so it's going to include 3, all the numbers to the right. So I'm going to actually, often it's bolded, but we draw a line with an arrow, and then to include 3, I make a square bracket. And the square bracket opens towards the numbers that I'm including. Alright, so this is a graph of x is greater than or equal to 3. Interval notation looks like this. So I take an interval. It's going to look very much like my graph. I'm going to have a closed bracket that says I include the number 3, comma, and I'm going to go all the way to the end. Well, we don't actually reach the end. We go to plus infinity, right? So we put the symbol for infinity. And because we could never get to infinity, it's not a number, it's just an idea or a concept, we put an open parentheses. So this is x is greater than or equal to 3 in interval notation. Okay, let's try another one. Let's graph and write the interval notation for x is less than 2. Just making these up on the fly here. So here's my number line, nicely straightens out for me. Here's 0, 1, 2. To the left of 0 would be -1, right? -2. But x is greater than, x is less than 2. So it doesn't include 2, but it's everything less than 2. So it's everything to the left. So I'll draw a line to the left with an arrow. And often this line is a bold line because you don't have different colors. It sits right on the number line. It's not above it. It's sitting right there on the number line. Because I'm not including 2, I have an open parentheses like that. Again, it opens towards the numbers I'm including. So if I write that in interval notation, it's going to be very similar. I'm going to write it below here. My interval, well, how far does that arrow go? It goes all the way, -2 million, -3 trillion. It keeps going, right? It goes to -infinity. So I write a -infinity, just like the number line, all the way to 2. But this time I don't include 2, so I have an open parentheses. That's interval notation. What I'd like you to do now is try both of these. X is greater than 1 and x is less than or equal to -2. Try graphing them and writing them in interval notation. Pause this video now and then I'll show you the answer. Alright, there are the solutions. I hope you got that. Now we're going to look at solving an inequality. So I'm going to write one on the left I'm going to write an inequality, and on the right I'm going to write an equation. Alright, so on the left I have an inequality greater than or equal to, and on the right I have an equal sign. Both expressions on the left and right are the same. To solve an inequality, it's very similar to solving an equals, alright, an equation. So let's think about how we'd solve this equation. Right, we'd probably subtract 5 from both sides, right, and we'd get 2x on the left, and then we'd get -3 plus x. Right, let's do the exact same thing to this inequality. It's not going to change anything. So on the left, I'll have 2x. I'll bring down, just like I brought down this equals, I'm going to bring down this inequality. Right, and this would be -3 plus x. Great, looks almost identical. Let's subtract x from the right-hand side over here, and I'm left with, on the left, I'm left with x equals, what have I got? The x's cancel out, right? So I'm left with x is equal to -3. That's my solution. Over here on the left, again, we're going to subtract x from both sides, and now I've got x on the left is greater than or equal to -3. That's one way of writing my solution. Now I should be able to graph this, right? Kind of a strange line, but let's call this -3, -2, should be horizontal, sorry about the slant. But if I'm going to graph this, x is greater than -3 or equal. So again, I'm going to have that square bracket. It's greater than, so it's going to the right. Put an arrow. If I wanted an interval notation, I can look at the graph. It's a square bracket, -3, and it goes all the way to plus infinity. Great. Pretty simple. I hope you can see how they're very, very similar. Now it's not really a problem, but it is a little problem in that you must remember one thing about inequalities. Something happens when we multiply by a negative number. So let's look at multiplying by a negative. And we know that multiplying and dividing are very similar, right? So let's start with something we know. We know what? We know that if I take 1, that would be less than 5. Clearly, it's on the number line, right? 1 is here, 5 is here, 1 is to the left of 5. Clearly, 1 is less than 5. If I multiply by 2, both sides, right? What happens? I get 2 here, and I get 10. Well, 2 is still less than 10. Again, 2, 10. 2 is to the left of 10. But what if I take this and I multiply both sides by -1? Now I have -1 and -5. Is -1 less than -5? No. Look at it on the number line. -5 is to the left of -1, right? -1 happens to be greater than -5. So the thing to remember is if I multiply by a negative, if I multiply by a negative number, it could be -1, -2, -3, what I have to do is reverse the sign. Alright, so if I multiply by a negative number, or divide by a negative number, right? We must change the direction of the sign of the inequality. Very, very, very important. So with that in mind, let's do this problem. Remember, I'm going to treat this as if it's an equal. I'm not going to write equals, but I'm going to pretend in some ways that this is equal, at least when I'm adding and subtracting a number. So when I add 5 to both sides, there's no problem, right? I leave the inequality just as it is. I get minus 2x on the left, I bring down the greater than or equal to, and I get 10 on the right. Now, I'm going to take both of these and divide by -2. Right, I'm going to take both sides and divide by -2. As soon as I do that, by the way, dividing by -2 is the same as multiplying by what? Yeah, by -1/2. So I'm multiplying in essence by a negative number, so this inequality, as soon as I make this division, changes direction, and it becomes a less than or equal to. So just as normal, the -2's will equal 1 and essentially cancel out, and I'm left with x is less than or equal to 10 divided by a -2, right, is -5. -5, here's 0, here's 1 on the number line. It's less than or equal to -5. Less than or equal to, square bracket, it goes all the way to -infinity. Or in interval notation, we have -infinity all the way to -5. Great. It's really important that you remember this, switching that sign around.